everyone, I hope you have watched the 2 videos on gas. Now we are going to discuss several tutorial and past questions from this subtopic. Let's begin with tutorial question. Question number 5. When an evacuated glass vessel weighing 134.74 grams was filled with an unknown gas Y, the pressure was found to be 99.3 kilonewton per meter square at 31 degrees Celsius, while the mass was 137.28 grams. The glass vessel was then filled completely with water and the mass was 1067.9 grams. By using the ideal gas equation, determine the relative molecular mass of gas Y. Since the question is quite long and quite difficult to understand, it is better if you sketch out this question. When the glass vessel is empty, the mass is 134.74 grams. When it is filled with gas, the mass is 137.28 grams. After that, the same vessel is filled with water. Can you guess what happened to gas Y as we pour in the water? Of course, it will release out. Means, mass of 1067.9 grams is actually mass of glass vessel plus mass of water only, without the gas. When gas and water are filled in the same glass vessel, what can you say about their volume? First, we calculate mass of gas Y and mass of water. We will get 2.54 grams and 933.16 grams respectively. Since gas Y and water are filled in the same vessel, so volume of the vessel is equals to volume of gas Y and volume of water. By using the formula for density, and density of water is 1 gram per mil, we will get the volume. Then, by using ideal gas equation PV equals to nRT, we rearrange the equation to get mR equals to mRT over Vp. Since the unit of R, the gas constant, is liter atm per mole per Kelvin, so the mass must be in unit grams, temperature in Kelvin, volume in liter, and pressure in atm. Finally, we will get the relative molecular mass of gas Y is 69.29 grams per mole. Question 7c. 4 liters of nitrogen at a pressure of 400 kilonewton per meter square and 1 liter of argon at a pressure of 200 kilonewton per meter square are transferred into a 2-liter container. Calculate the partial pressure of nitrogen, the partial pressure of argon, the total pressure of the mixture. Again, we can sketch out the question for better understanding. When nitrogen gas is in 4-liter volume container, the pressure is 400 kilonewton per meter square. For argon, when it is in 1-liter volume container, the pressure is 200 kilonewton per meter square. When both gases are transferred into 2-liter container, will their pressure change? Yes, of course. What is the gas law that relates between volume and pressure? Yes, Boyle's law. The formula is P1V1 equals to P2V2. By applying P1V1 equals to P2V2, we can calculate partial pressure of nitrogen and argon. Partial pressure of nitrogen is 800 kilonewton per meter square, while argon is 100 kilonewton per meter square. Total pressure of both gases is just the summation of the two. The answer is 900 kilonewton per meter square. Let's continue with PSPM question. PSPM 1 2013-2014. Figure 1 shows 2 connecting vessels containing different gases. When the valve between the vessels is opened, the gases are allowed to mix. Ignoring the volume taken by the valve, calculate the partial pressure of each gas and the final pressure of the mixture at 25 degrees Celsius. When the valve between two vessels are open, now both gases can occupy a larger volume. The new volume is 1 liter plus 3 liter becomes 4 liter. By using ideal gas equation, we then can calculate the new pressure of hydrogen and carbon dioxide gas. And the total pressure is just the summation of that two. Next question, PSPM 1 2016-2017. Ethane C2H6 burns in the air according to the equation below. A mixture of ethane and oxygen at 30 mm mercury and 124 mm mercury respectively was added into a 7.5 liter flask at a temperature of 37 degrees Celsius. The combustion reaction was carried out until completion. Calculate the total pressure of the gas mixture obtained at the end of the reaction at the same temperature. Give your answer in millimeter mercury. At the end of the reaction, what are the gaseous compounds that still present? Of course, both products, carbon dioxide and water, also one of the reactant, either ethane or oxygen, because one of them must be the limiting reactant, while the other one is in excess. Firstly, by using ideal gas equation PV equals to nRT, we can calculate number of moles of ethane and oxygen. Moles of ethane is 0.012 mole, while oxygen is 0.0497 mole. After we get number of moles of both reactant, we have to determine the limiting reactant, because limiting reactant will determine amount of excess reactant that left after the reaction. From the stoichiometry, we get ethane as the limiting reactant, while oxygen as the excess reactant. Now, we know that the gaseous compound that's still present after the reaction are carbon dioxide, water, and excess oxygen. Next, by using stoichiometry, we can calculate moles of oxygen reacted, moles of carbon dioxide and water produced. Then, we can determine moles of excess oxygen. After that, by using PV equals to nRT, we can calculate the total pressure, where N is the total number of moles of the gaseous compound. The final answer is 168.87 mm mercury. Thank you for watching.